Hey guys, we are going to do the next lesson of Unit 11. This is actually going to be our last lesson on factoring. And this one is called Factoring Special Products. So every one of these problems that we're going to do today are unique, and they have their own own names of how you actually factor them and what they look like when you get your final answer. So let me show you what I'm talking about. So this first one is called a perfect square trinomial. Let's break this name down and figure out why this would be called that. So first of all, the easiest word is trinomial. Trinomial means it has three terms. So it in fact does have three terms. Okay. Perfect square. So we haven't seen this word in a while. This is what we were doing right before we had to leave school. Every time we did these, when y'all took a test on these, I made y'all write your list of perfect squares down the side of your paper. So this is what I was talking about. So like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So hopefully those are remembering in your head right now of how to do a list of perfect squares. So what makes a perfect square trinomial is the first and the last term are from the list of perfect squares. So for instance, if I have x squared, the number in front is a 1. 1 is a perfect square. 36 is in the back. 36, let's see, 3 times 3, 4 times 4, 5 times 5, 6 times 6. So yes, 36 is also a perfect square. So what makes a perfect square trinomial is the first term and the last term are perfect squares. Okay, so let's try to factor these just like normal, like we've been factoring over the past few weeks. And let's see what happens when you factor a perfect square trinomial. Okay, so we need our two sets of parentheses because we know it's going to turn into a binomial. Okay, so we start with our term in the front. So this looks like Unit 11 Lesson 2 when there's not a number in the front. So this guy right here is super easy. The only way to split x squared is with an x and an x. Okay? All right, so 36. So I need to list my factors of 36. So let's see. 1 times 36, 2 times 18, 3 times 12, 4 times 8, 5 doesn't go into it, 6 times 6, and that would be all of them. Okay, so what we need and our rules for factoring is I need a number that multiplies to get me 36, which is all these that we've listed here, but adds to get me 12. So which one of these on our list adds to get you a 12? And that would be 6 and 6. So 6 here, 6 here. Okay, now our rules for the signs. If your second sign is positive, these signs will be the same. You look to the front to see what they're both going to be. So these are both going to be a plus sign. Okay, so let's take a bigger look at what our answer just looked like. We have an x plus 6 and an x plus 6. They're exactly the same. Now remember, these are two parentheses they're stuck together. They're two binomials stuck together, which means they are being multiplied. So I would never leave my answer x times x and that be my answer. What is x times x? It's x squared. So instead of leaving x plus 6 times x plus 6 as your final answer would be x plus 6 squared because there's two of them. Okay. All right, let's take a jump to number 2. All right, so we've now stepped it up where we have our coefficient in the front. So this is like last week's lesson. So we need to make our list of perfect squares. Double check, see if these are on it. So 1 times 1, 2 times 2, 3 times 3. Well, there they are. They're both on there. Okay, so this is in fact called a perfect square trinomial. The first term, the last term are both perfect squares. Okay, so let's make our list so we can begin factoring. So 4, 1 times 4, 2 times 2. Okay, 9, 1 times 9, 3 times 3. And that's it. All right, so we're going to make our binomial. All right, so this is the one where we needed to have a really good eraser. We need to double check to see, we'll do a little smile, big smile, double check to make sure we are in fact getting negative 12. So let's just try, I'm going to try 1 and 4. So that would be an x and a 4x. And then let's try 3 and 3. All right, second sign is positive. That means these will be the same. You look to the front, they're both going to be negative. All right, so let's double check it. Little smile, big smile. Little smile gets me negative 12x. Big smile gets me negative 3x. If I add that together, I get negative 15x. So, no, we did it wrong. Okay, so let's kind of think back to what we just did on number 1. Perfect square trinomial. This guy's was the same because it was perfect. These guys were the same. Let's try that method. Let's see. If I take and leave the 3 and the 3, but use 2x and 2x instead, let's see. Little smile gets me negative 6x. Big smile gets me negative 6x. Add that together, you get negative 12x. Perfect. Okay, so here's your little hint. If you have been given a perfect square trinomial, both parentheses are going to match because this is a perfect square and this is a perfect square. Always double check to use little smile, big smile just in case, but it's most of the time always going to work out that way. So let's write our answer because 2x minus 3, 2x minus 3, we would never leave our answer that way. So 2x minus 3 squared. Okay, so last one of the perfect square trinomials, and let's see if we can use our shortcut on this one. Let's see if our first term is a perfect square. Is 81 a perfect square? Yes, 9 times 9. Okay, last term, is 25 a perfect square? Yes, 5 times 5. So, let's use our little trick, little shortcut here, save us some time. I know that I can split 81x squared with a 9x and a 9x. And I can split 25 with a 5 and a 5. Okay, so second sign is positive. These will be the same. You look to the front. These are both going to be a positive. All right, let's see. Let's check with little smile, big smile. Make sure that we were right. So little smile, 5 times 9x would be 45x. 9x times 5 would be 45x. Add those together, you get 90x. Yes. Okay, so there's your little shortcut. If you have a perfect square trinomial, this one's perfect, this one's perfect, the parentheses will be exactly the same. So my final answer, 9x plus 5 squared. All right, so different kind. This guy is called a difference of two perfect squares. So let's break down that name and see why they call it this. So again, I see two perfect squares. Okay, difference in the first 3 problems is it said trinomial, meaning 3 terms. This guy says 2. And if you'll notice your problem, you've only got 2 terms. But let's see, it says 2 perfect squares. So you need to double check, make sure, is this a perfect square? Is this a perfect square? So this would be a 1 right here. Yes, 1 is a perfect square. Is 49. What times what gets me 49? 7. So yes, okay, so there are 2 perfect squares in my problem. The big point you need to get out of this name is the word difference. What does difference mean in math? It means to subtract. So you have to have a subtraction sign in the middle of these 2 terms for this to work, for this to be called a difference of 2 squares. So let's see. If I'm used to factoring a trinomial, what would this actually look like if it was a trinomial? X squared, what is it missing? It has a squared and it has a constant. What is it missing? It's missing an x. So there's no x's. There's 0. There's nothing there. Okay, so let's try to see if we can figure out what this is going to be. So this guy's easy. How do you split x squared? X and x. Okay, 49. So we've been talking about the word perfect square. So the perfect square is going to come into play here. 49 is a perfect square because of 7 and 7. Okay, so let's get our signs. If the second sign is negative, these will be different. They will be different. So that means one of them is going to be a plus and one of them is going to be a minus. Okay, so remember, our whole goal was to get this guy in the middle. Now, we don't see it in the original problem, so you're going to have to kind of think, hey, what's it missing? There's a 0 in there. There's a 0x. So let's do little smile, big smile to see if we do get 0. Little smile would be 7x. Big smile would be negative 7x. 7x minus 7x is nothing. So that's why there is nothing written in here. That's why this is not a trinomial. There's only 2 terms because the middle term is 0. Okay, so let's see. Can I write my answer the way that we wrote the answer on 1, 2, 3 with the square? Are these exactly the same? No, they're not. This one is a plus 7 and this one's a minus 7. So that is in fact all you can do. That is your answer. X plus 7, X minus 7. Okay, let's take a look at this one. All right, so let's break down the name again. Make sure that it is in fact a difference of 2 perfect squares. So difference hits me first. Is this in fact a minus sign? Yes, so it's a difference. Okay, 2, are there 2 terms? Yes. Perfect squares. Are those 2 terms perfect? So is 9 perfect? Yes, 3 times 3. Is 16 perfect? Yes, 4 times 4. So yes, this name is in fact a difference of 2 perfect squares. So our 2 binomials. So remember, what's missing? There's a 0 missing right here. So keep that in mind. How would I split 9x squared? So if I'm dealing with perfect squares, that would be a 3x and a 3x. All right, and then 16, he's a perfect square. How would I split him? Perfectly, 4 and 4. So you have to remember on the difference of 2 squares, the second sign is negative because this is your constant. So he's actually your second sign even though you don't see the 0. That means these guys will be different. One's a plus, one's a minus. All right, so let's double check. Remember, the whole goal is to get 0 because there's something missing here. So little smile gets me 12x. Big smile gets me negative 12x. Perfect. That would be 0x. So yes, our final answer is 3x plus 4, 3x minus 4. All right, last one. All right, there's something a little different about this one. So let's kind of think about what looks different here. I have a normal 25x squared. Pretty simple, a minus. But then I have this guy that shows up. Let's make sure he matches the name. Difference. I got my minus sign. That's good. 2. There are 2 terms. Perfect square. So are both of those terms perfect? 25x squared. Yeah, 25 is 5 and 5. 36y squared. How would I split that guy? So 36, 6 and 6. How would you split y squared? Y and y. Okay, so here we go. Little smile. 2 binomials, so I've got 25x squared would split with 5x and 5x. 36y squared would split with 6y and 6y. Okay, second sign, remember because you're missing the 0 in the middle, the second sign is a minus, so these will be different. One's plus, one's minus. All right, so let's check it and see if we do in fact get that 0. Little smile, how would I multiply a 6y and a 5x? So do your coefficients first. 5 times 6 is 30. Y times x. Okay, we got to think. They're just going to be multiplied, stuck together, but you got to put them in alphabetical order. So that would be xy. Okay, big smile. 5x times negative 6y. So that would be negative 30. And then x times y again is xy. And then yes, that would get you 0. So my final answer, 5x plus 6y, 5x minus 6y. All right, guys, there you go. There's your lesson on, these are called special products. So the 2 that we learned were perfect square trinomials and difference of 2 perfect squares.